Hello everybody, welcome to another lesson. Today we are going to be talking about simplifying algebraic expressions or collecting like terms. So let me write that on the board here. You may see it told to you like this: collect like terms. You may be told in your math books or by your teacher to collect like terms or simplify. That's another way it's often written, is simplify. Well, first things first, we have to understand about these types of equations, okay? What it comes down to is you say you have your variable equation here, 7x plus 4, for example. That's just an example. Of course, x is your variable. And the term that's 7 on the x there, it's 7x. Well, that 7 is called the coefficient. If it were just x, it would be 1x. 1 would be your coefficient. So that 7 on the x there is your coefficient. Then on the second term, because each of these, the 7x and the 4, are considered two terms, those are considered terms of the expression. But the 4 is just a constant. If you see a number by itself, it's called a constant. So the idea is that you can simplify these equations. So for example, let's say you have 2x plus 5x. You got 2x plus 5x. Well, to simplify, what you're going to do is you want to take all the terms that have the variables that have the same variable, you add them together. So how do you do that? 2x plus 5x, you just simply add the coefficients. So 2 plus 5 is 7, then you have x. So that would be the answer. To simplify this, you add the coefficients of the x terms, which would be 7x. 2x plus 5x is 7x. Alright, how about another? We have 7b plus 2b. Well, 7b plus 2b, both terms have the variable b, so we can add them together. So we have 7 plus 2, when you add the coefficients, you'll get 9b. You just add the coefficients and keep the variable, you got 9b. That would be your answer for this, when you add the coefficients and keep the variable. Another one. Alright, we got y plus 10y. Y plus 10y, well, again, you're going to keep the variable because they both have the same variable. You're just going to add the constants. That y is 1y, so you'll add 1 plus 10, that would equal 11. So the answer you would get when you simplify or collect like terms, however your book words it, is 11y. And remember, each of these be, on either side of the plus sign, those are called terms. Your terms, if you're asked to list your terms, are going to be y and 10y. Those would be your terms. So on each side of an operation sign, those are your terms. Alright, we have 2a plus 3 plus 5a. Okay, this is a little bit different here. Because we have two terms that have the same variable, then we have a constant. So in order to collect like terms or simplify, you start with your variable terms. You have 2a plus 5a. Well, you're going to add the coefficients. 2 plus 5 would be 7a. Then you just have 3. You can't do anything with that, so it will just be 7a plus 3. If we had another constant, you would add the constant to 3 and you would get a simplified result. So 2a plus 5a, when you add their coefficients, that gives you 7a. Then you just have plus 3. So that's all you could do with something like that. Alright, then we have 4 plus 2m plus m. Well, first thing I would recommend, again, look for like terms. Well, 4 is a constant, but you have two terms that have the variable m in it. So you know those are like terms. 2m and m, these together, these are what are called like terms because they have the same variable. They're like terms. You can add like terms together. 2m plus m, well, that'd be 3m. And then you just have that 4 plus 4. You can't do anything with that 4, so it's just 3m plus 4 when you simplify. Alright, what's next? Alright, we have 2y plus 8 plus 5y plus 1. So we're going to collect like terms or simplify the expression 2y plus 8 plus 5y plus 1. So again, I would start with your variable terms. Add your coefficient of 2y and 5y, since those are like terms, since they have the same variable, they're like terms. Add your coefficients, 2 and 5, that would give you 7y, plus, now you're going to add your 8 and 1, you just add your constants together, 8 plus 1 is 9. So the answer you would get is 7y plus 9, when you add your like terms together. Yes, constants will always be like terms. Alright, we have simple one here, 5x minus 3x. Well, this time we're doing subtraction of like terms. So you just subtract the coefficient. If you subtract 3 from 5, that would give you 2x. You keep the x, you just simply subtract the coefficient, and you get 2x. That would be the answer to that. Alright, how about 8 plus x minus 5x? So we have 8 plus x minus 5x. Well, we can start with our variables here. We'll leave the 8 alone for a minute, because we see x and minus 5x, those are like terms. So x, you just simply subtract the coefficient of 5 from 1. So 1x minus 5x, well, that'd be negative 4x. Then you have plus 8 hanging out. So you may be able to write it as negative 4x plus 8, or by the commutative property, you could write it as 8 minus 4x. Either way is okay to write it. When you use the commutative property, you could write 8 minus 4x. Alright, we have 6x plus 4 minus 7x. So we got 6x plus 4 minus 7x. Well, you see two like terms. You see 6x and negative 7x. Those are your like terms. 4 is a constant, just hangs out by itself. So I would do 6x minus 7x, just subtract the coefficient from 6x. 6 minus 7 is negative 1, so you'll have negative x, and then you just have plus 4. So you could write this as negative x plus 4, or by the commutative, you can do 4 minus x. Either way will give you the same solution. By the commutative property, it would be 4 minus x. So, again, just look for the coefficients on the like terms. You add or subtract, and then that's really all there is to it. You just keep the variable. It's pretty much like addition and subtraction, only keep the variable. Alright, so let's see. We have 2x plus 3 minus 3x, and then what's the last term? Plus 9. So we have the expression 2x plus 3 minus 3x plus 9. So identify your like terms. 2x and negative 3x are like terms because they have the same variable, x. And then the constants 3 and 9, those are like terms because they're constants. So let's start with your variables first. Again, add or subtract the coefficients here. You have 2x minus 3x. That would just give you negative x. Because 2 minus 3 is negative 1, you just have negative 1x. Then you have positive 3 plus positive 9. Well, that would just be 12. So you would get negative x plus 12, or by the commutative, you can do 12 minus x. Either way would be a correct answer. You could do either way, because you have 2x minus 3x, again, it'd just be like 2 minus 3, only you're keeping the x on there. 2 minus 3 is negative 1, negative 1x, which is negative x, and then 3 plus 9, well, that's 12. So you have negative x plus 12, or you can write it as 12 minus x by the commutative property. Either answer is correct. Alright, so that's with one variable. Now, let's say we have two variables. Well, we have two variables now all of a sudden. So, again, like you would before, you're going to look for like terms. 6m and 10m are like terms because they have the same variable. You can add the same variables together. So 6m plus 10m, that's 16m. 2n, it's on its own. That's the only term with the variable n. So you would just have 16m plus 2n. And unfortunately, there's nothing else we can do with that. It would just be 16m plus 2n. Because when you add the coefficient of the m terms, 6 and 10, you get 16m. And then n's a different variable, so you just simply add the 2n. So that's all you can do with that. I got more. Alright, how about negative 2y plus x plus 3y? So we got the expression, negative 2y plus x plus 3y. Okay. Well, what we're going to do first, look for like terms. It looks like negative 2y and positive 3y, those are like terms because they have the same variable of y. Then you have a term that has x, which kind of stands on its own. So look for your like terms, add them together. Well, negative 2y plus 3y, that would give you positive 1y. You would get y, then the x hangs out its own, so you'll have y plus x. The answer would be y plus x. That's all you could do, because negative 2 plus 3, that's positive 1. You'll have positive 1y, then just simply that x. You can't add the coefficients of y and x because they're different variables. They have to be the same variable in order to be able to add them. Oh, here's a good one, because this has a distributive property in it. A little bit of review from yesterday. We have c plus 2 times d minus 5c. This has a distributive property. Well, of course, first thing I would do, again here, do your distributive property first. Remember, parentheses always come first in the order of operations. In this case, using the distributive property would count as that. Which would actually count as multiplication, but multiplication comes before addition. But of course you'll write c plus, now remember when you distribute you would do 2 times d, so it would be 2 times the first term plus 2 times that negative 5c. You'd have, so it would be 2 times d plus 2 times that negative 5c. Now, of course, we're going to do our multiplication. We'll have c plus, what is 2 times d? That's 2d. Plus, what is 2 times negative 5c? Well, that's going to be negative 10c, which is going to equal c plus 2d. Now, plus a negative, that's just minus. That'd be minus 10c. Alright, now we can look for like terms. While c and negative 10c are like terms because they're the same variable, that 2d is on its own because it's a different variable. So you'll subtract, you'll do 1c minus 10c. That would give you negative 9c. And then you'll just have plus 2d. So that's one way you could write it. Or if you want to use the commutative property, you could switch it around. You can do 2d minus 9c. That's another way you could find it written as 2d minus 9c. Either answer would be correct. But that was a good review one because it brought in the distributive property. Alright, let's see another one with the distributive property. You have 3 times the quantity of b plus 2 same variable, plus 2b. Alright, well of course you're going to do your distributive property first because multiplication comes first. So you'll have 3 times b plus that 3 times 2. So 3 times b plus 3 times 2, then plus 2b. Okay, next you'll do your multiplication again. 3 times b as well, 3b. Plus 3 times 2, well that's 6. Plus 2b. Alright. Now, since we've done our distributive property and simplified it from the distributive form, got rid of the parentheses, now we can just look for like terms. 3b and 2b are like terms because they both contain the variable b. 6 is a constant, so that's going to hang out on its own. So now we'll just add the coefficients of 3b and 2b. Add those coefficients, you'll get 5b because the variable stays, and then you just have that constant 6. So the answer we're looking for here is 5b plus 6. Alright. I got a little more. I'm not going to dump you here. Alright, why don't we do negative 3 times a plus 2 minus a. So we got the expression negative 3 times the quantity of a plus 2 minus a. Well, again, do your distributive property first because multiplication always comes first in the equation. So you'll have negative 3 times a plus that negative 3 times the positive 2, all that minus a. So negative 3 times a plus negative 3 times 2, then minus a. So next, do your multiplication again. You'll get negative 3a plus, what is negative 3 times 2? That's negative 6. Then you have minus a, which we can rewrite this as negative 3a plus negative 6 is minus 6. Then we just have minus a. Okay. Now that we've undone the parentheses in the distributive property, we can find like terms. We have negative 3a and negative a. Those are like terms because they both contain the variable a. That negative 6 will hang out on its own since it's a constant. So we do negative 3a minus a. That would be negative 4a. And then just the minus 6. So your answer is going to be negative 4a minus 6. That's all you would get. Alright. I'd like to do one more, and then I think that should be it. What are we going to do here? Yes, we'll have 8a minus 2 times a minus 7. Okay? So, we have 8a minus 2 times a minus 7. Again, do your distributive property first. Well, first, let's rewrite this here. It's going to make our lives a lot easier for the distributive property. When you minus, you add a negative. So you'll have 8a plus negative 2 times a minus 7. So you would have 8a plus negative 2 times a minus 7. Now we can go ahead and do our distributive property. You'll have 8a outside, of course, plus you'll do your negative 2 times a. You'll have negative 2 times a, plus you'll do your negative 2 times your negative 7. Alright, now you do your multiplication since you've dealt with your distributive. You'll have 8a plus, what is negative 2 times a? That's negative 2a. Plus, what is negative 2 times negative 7? Positive 14. So, we can rewrite that 8a plus negative 2a plus negative is minus. That would just be 8a minus 2a plus 14. Alright, now we just look for the like terms since we've undone the distributive property and all the parentheses. You want to do 8a minus 2a. That'll give you 6a because those are your like terms. And then you just have 14 hanging out here by itself. So you would just get 6a plus 14. So again, whenever you're asked to collect like terms or simplify these type of equations, if you have parentheses, always do away with your parentheses first. It'll often take the form of the distributive property, and then you'll have multiplication parentheses like you see here. Do away with that. Simplify it down to an equation with like terms, and in order to add or subtract like terms, you just add or subtract the coefficient of the same variable. They have to have the same variable. If it's a different variable or constant, you can't add that to the coefficient of one variable or another variable. And of course, coefficients will always be like, constants will always be like terms to each other. So that's the big giveaway. That's the big takeaway here. So next lesson, we are going to solve simple algebraic equations that have a variable where you have to add or subtract in order to get the solution. So stay tuned for that. I hope everybody has a good night. Take care.